Oh, yeah.
We are. We need you. We want you.
Okay, detail what transduction is. Describe how transduction occurs when perceiving visual stimulation. Or just stimulation. Sensory. There you go. Not just visual. You're asking me for something again, huh? Go ahead, hurry up. All right, so what do we got here? What is transduction? Describe how transduction occurs when perceiving sensory stimulation. What do we got? What do we have? Brady, what do you got for transduction? What?
I don't know. That's not
Dude, what?
That's what comes up. Search it.
Oh, gosh.
The sensory process that converts.
Okay, there you go. All right, there you go. There you go. Yep. So transduction is just the process of neural messaging sending to the brain and how we're perceiving this information, this sensory stimulation. Okay. And we talked yesterday a little bit about auditory processing. We talked a little bit about visual processing and really just how we're perceiving that information. What example did I give yesterday of this? And I think I included the example of going to a grocery store or Walmart. What did I say? Kiara? Huh? The barcode scanner. Yeah, good job. So again, when you're slicing, putting an item across the barcode scanner, it sends that information, electrical signal to the computer, and the computer knows exactly what object or what type of grocery you're buying. And it's the same way with transduction. Our brain doesn't actually interact with the outside world. We perceive information through senses. And transduction allows us through this neural messaging, this neural energy being sent to our brain to perceive what is really going on, what is the sensory information that we are receiving. All right, and yesterday we talked about sensation and perception, and really just along the lines of transduction. All right, is there any questions on that? Brady, you got that fixed up? Okay, good, good. All right. So today I want to talk a little bit about absolute threshold. I want to talk about signal detection theory. I want to talk about sensory adaptation and a couple laws that belong to this sensory adaptation and just noticeable difference. Okay, so terms for today. If I have to zoom in, let me know. Should be able to see them though. Or maybe not. Maybe I do have to zoom in a little bit. All right, how about I zoom in and I'll just move down the line. Okay, sensory adaptation, absolute threshold, difference thresholds, just noticeable difference, Weber's law, Beckner's law, and I'll just move down as we're going through. Give you a little bit of time to write these down. We'll go over them, and I'll move the line down then for you. All right, so what do we have for sensory adaptation? And we'll move down the line here once we finish up these here. Sensory adaptation, what we got? Raven, what do you have?
Don't have it.
You don't have it. What are you doing?
Writing down all the words.
Oh, so you didn't get to define them yet. Okay. You guys need another minute? All right. So I'm sure everybody has sensory information or sensory adaptation written down, right? Can I scroll down then a little bit? I think that's it. Just these two though. Where you at here, Brittany? So you're good? Okay. And then the last one's signal detection theory. The last one's signal detection theory. All right, let's get to it here. So sensory adaptation. What does it mean? What is sensory adaptation? Raven, go ahead.
It's the reduction in the sensitivity for stimulus after constant exposure.
Okay, yeah, good job. Good job. So after, let's say something's playing for a long period of time. I don't know if you're playing music. And after a while, you start to adapt to it. You forget that it's even playing. And that is, again, what sensory adaptation is. We are perceiving a stimulation for a certain amount of time to a point where we just adapt to it. We just forget it's kind of even going on. What example can you maybe come up with? Natalie, what example do you think you can come up with for sensory adaptation? Okay, all right. So you're saying like an emotional adaptation to it? Okay, all right, good, good. Yeah, I definitely feel that, especially if we hear a new song over and over again. It's like, okay, at first I was really into it, but not anymore. Just kind of adapt to it. Allison?
If you're trying to do homework and there's
Okay, all right, yeah. You just kind of block it out after a while, right? Good job, good job. Do you already have any examples for sensory adaptation?
you're getting yelled at like all the time.
So you just block it out? All right. Okay. Yes, you're just getting yelled at constantly, and you just kind of adapt to it. You just forget that it's even going on. A good example, maybe the air conditioner going, right? At first, maybe in a quiet room when you're taking a test, might get a little annoying at first, but then you adapt to it, right? You adapt to it. Or just sitting in your seat. Okay, obviously, there is going to be some sort of discomfort when you first sit in your seat. Okay, after a while, you just get used to it, right? And then maybe eventually, once you're sitting in a seat for 45 minutes, you get a little bit of antsy, and you're like, okay, this is uncomfortable. I want to get out of the seat. All right, that's a good example of it too. So sensory adaptation, again, is just our way of adapting to a stimulus, right? Adapting to whatever might be happening. I know right in the morning, okay, when you wake up, are you happy that the light's on? You happy that the sunlight's coming through? No, you're like, oh, geez, this is ridiculous. All right, I don't want to be up right now. The sun is too bright. And then eventually you just adapt to it. Then you start waking up. Your photoreceptors are starting to cling on to and perceive that, well, this light stimulation is occurring and I need to wake up. So that's sensory adaptation. There's many other instances that you can maybe relate to, maybe at a concert. At first, it might be uncomfortable how loud the music really is, but eventually you just adapt to it. You start to get in a groove and you start really, you start to communicate maybe with friends eventually that you can adapt to that your environment, your surroundings. All right. So again, this is kind of the examples that we're talking about that we're already experienced. Obviously, with pain. Okay, maybe if you have an injury on the athletic field, maybe you just block it out after a while. You start to adapt to the pain in order to play through it. Right, Christian? Yeah. What did you have? An ankle injury earlier in the year? Or no, it was your thumb or something like that. Both. Okay. All right. You just adapt to it though, right? You just kind of block that pain out and you're able to carry the ball and have a successful season. Brady, you too, I guess, right? Your concussion. Yeah, that was a little that's something that maybe you shouldn't try to adapt to, right, Brady? And that's something that maybe we should take some time off. But sensory adaptation occurs in every instance, right? It's constantly occurring. Um, like I said, there's many different examples you can come up with: auditory stimulation, visual stimulation. Maybe it's just pain. Maybe it's just touch. Okay. There's a lot of things that you can maybe adapt to. Smell, the aroma of different things as well. I know Thanksgiving, I hate the smell of sweet potatoes when they're cooking like yams. And then after a while, I'm like, oh, okay. I start to adapt to it. I start to get over that strong smell of maybe different foods that are cooking. All right, thresholds. So absolute threshold. Okay, we kind of talked about this with neural firing, okay, and how that is first triggered. Absolute threshold is just the first detection of a stimulus. Okay, the first, really, let's say, a sight of light. Okay, when we're visualizing light for the first time, how faint it is when we can first detect it. Right, that is the absolute threshold. Maybe it's sound, right? When we can first detect a sound being played. And yesterday we kind of did that, right? With that buzzing sound of different age groups, depending on how high pitched that sound is. I know after a while I couldn't detect it anymore, right? And my absolute threshold couldn't perceive that auditory stimulation any longer. But again, absolute thresholds are first, I guess you say, perception of a stimulation. When first triggered. I'm sure you guys did some hearing tests back in the day. We're like, oh, when you first detect it, raise your hand, right? You guys remember doing some auditory testing? Yeah, when we put the earphone, the earbuds on you. They're asking when you first detect it, raise your hand. That's a good example of when your absolute threshold's being triggered. All right, so certain instances, it's not for everybody, right? Everybody's absolute threshold might be different or triggered differently. And that just goes along the lines of maybe there's a disability, maybe there's an impairment that might cause other people to might have a heightened sense or a lowered sense of perceiving information. And here is just in the book, the textbook, it described about how we can detect our absolute threshold. This is just a generalized view of our absolute threshold. So light, a candle flame at 30 miles on a dark, clear night. 30 miles, a candlelight. I don't know about that. Maybe Paul Revere back in the day could see it, right? Yeah. What is it? One by water, two by, I don't know what it was. Can't remember. Ask Mr. Henninger, he'll know. Raven, do you remember it? What's that? Yeah, I just didn't really focus much on the revolution, I guess. Sound. What do we have for sound here? It says tick of a mechanical watch under quiet conditions at 20 feet. I know when I'm sitting at home and maybe it's quiet, I can hear the clicking of the clock. And that after a while gets annoying. But then again, you adapt to it depending on what might be going on, your selective attention. Taste, 1 teaspoon of sugar and 2 gallons of water. I don't know about that one either. Smell, 1 drop of perfume diffused in an entire volume of a 3-bedroom apartment. I think I could pick up on that. These different types of perfumes and fragrances. Oh, I can't stand it sometimes. Touch, the wing of a bee falling on your cheek from a distance of 1 centimeter. I don't know, maybe. Again, that's just generalized in your book of some of the triggers of absolute threshold. And again, not everybody can feel this types of absolute threshold, especially depending on what you might be performing at the time, depending on what activity you're maybe getting involved in. Maybe you're, let's say, at a concert. Obviously, some of your senses might be inadequate at the time. So thresholds, difference threshold is the smallest amount by which a stimulus can be changed and difference can be detected. We'll talk about certain laws today and how this could be altered and how our difference threshold might be skewed depending on the situation and depending on really what we're trying to perceive at the moment. So difference threshold is that certain change of a stimulus after a while. So sensory adaptation again is just how we adapt to a stimulus after a while. Okay. Difference threshold is that first detection of a change in a stimulus. So a good example is if you're driving your car and you're turning up the volume. Right when you first notice the volume going up, changing, maybe being obviously higher, then you can notice that change. You can notice that change. All right, so goes along with it, just noticeable difference, okay? This is very similar to what difference threshold is. It's just, again, how we notice a difference in a stimulus, right? That first signal, that first appearance of the stimulus being altered. Again, it might be a bright light, okay? When we notice that light being brighter. It might be a sound when we notice it's getting higher or lower. It might be touch, right? The feeling of a certain object. It might be more pressure or less, depending on our threshold. So just noticeable difference, the minimal amount of change in the signal that is still recognizable. So we first detect a change in the stimulus. Used to run a simulation. You guys remember Isaiah Wenrick? He was a big guy, so I had a backpack on him, and I used to just drop. I used to drop like items in. So one time it was a paper clip. I said, "Oh, do you notice a change in the absolute threshold? Do you notice a change in the stimulus of the weight?" Nope. Threw a paper in. Nope. I put a book in. Yep, noticed it. Okay. And then I just jumped on his back. It was kind of funny. It was kind of funny. Obviously, shouldn't be doing that, but for Isaiah, he could definitely hold the weight. All right, laws of sensation. Weber's law, Fechner's law, and Stephen Powers' law. So Weber's law and Fechner's law kind of go together. And this is really just the minimal amount of change that we can detect in a certain stimulus. All right, so with Weber's law, he believed that 2% of a change would be noticeable. And a lot of people argue that. It's like, well, 2%. Well, if you have the volume up to let's say 90 in your car, that's really loud. It's almost deafening. If you just put it up, let's say 2% more, 92, you won't notice that difference. Okay, so that's why a lot of people argue and kind of combine Fechner's law with it. Right, but when you're looking at pricing, when you go shopping, I know Black Friday just came around, and when you're looking at pricing of an item, maybe let's say it's $1 off. I don't know, let's say $1 off a box of cereal. Okay, box of cereal is what? Like usually $3, maybe a little bit more now. But $3, let's say $1 off of that, that's a pretty good deal. When you're looking at the percentage change, that's pretty big, okay? That's really big, actually. It's almost 30% change. Well, a little bit more than 30% change. But when you're looking at $1 off, let's say a shirt, that's $60. Are you gonna take that deal? Christian, are you gonna think that's a really good deal? No, why not? When you're looking at the percentage change, it's not much of a bargain. But at the same time, what do you save? $1. Why do you perceive it so different, though? Okay, all right, yeah. So the percentage change is totally different, right? But at the same time, you're saving $1. Think of it that way. Right? But anyway, Weber's law and Fechner's law kind of describes that change. It's like we're perceiving this as, even though we are saving the same amount of money, $1, we see the percentage change, which could be totally different, which might change our opinion of a certain item. So again, that is just kind of the idea of perception of how change occurs, right? And even though we're saving that $1, the percentage change is totally different. All right, so signal detection theory, last thing I want to talk about is how we are perceiving a lot of stimulus all at once and we detect a stimulus that we have no idea what the perception is, right? We have no idea what is causing, let's say, a stimulus to occur. So a good example is if you're driving your car down the road. You have the volume on, you're obviously paying attention to the road. Hopefully none of you are texting and driving. Hopefully not. No, cross your fingers. All right. And all of a sudden you hear a rattling in your car. Did anybody ever experience that? A rattling in your car, maybe a sound that you have no idea where that sound's coming from. At first you're worried, right? You're like, what's going on here? Is it something with the, I don't know, the axle, the transmission? Is it something with the tire? Do I have a loose bolt or something? I don't know. I don't know. So what do you do? What do you guys do when you start hearing a rattle in your car? Raven, what do you do? Maybe I shouldn't ask you. I'm sorry. All right. Is that too soon? I'm sorry. We're recording. Oh, okay. What do? You just turn the volume up and say, forget about it. Just keep going.
Actually, yeah, like
That's what I usually do too. Yeah, that's what I usually do too. Yeah, okay. I'm sure we all have an example of that though when we're driving. It's like, oh, what is that rattling noise? Well, signal detection theory is that idea where we're detecting a stimulus, but we have no idea what's being caused by. We have no idea what that sound might be or what that stimulus might be. Right, Noah?
Hey, I knew it last time.
Yeah, you knew exactly what it was, right? You saw the deer run out. What do you do? Let go? Oh God!
No, I'm gonna scream the curse word.
Oh geez. Okay.
Because I knew I was hitting it.
Yeah, that's a good. Yeah. Another example of signal detection theory would be, let's say just back to absolute threshold. Okay, you're watching TV. I always record some shows, especially if I'm not able to watch it all at one time. And you're recording a show, and all of a sudden you play that recording after the fact. And all of a sudden you're playing it, and you're like, oh, I can skip through the commercials. I can really get through this, no problem. All of a sudden you're sitting there, and the commercial's playing, and you don't hit the fast forward button. Does that ever happen to you guys? You don't record shows. Why not? Oh my gosh.
Actually, I do. I was in Survivor.
Oh, there you go. There's a lot of times when you're recording, you're just watching a commercial and you're like, oh, what am I doing here? I keep going. Yeah. That's a good example of absolute threshold. Maybe it just doesn't cross right away. And you kind of look foolish after a little bit. Geez, I keep doing it. I'm wasting time. But maybe your selective attention's focused on something different. Maybe like your phone. I don't know. Another good example. There's a lot of times I feel like this is a superpower of all dads. Whenever I'm watching like a show with my dad and he falls asleep usually on the couch, he's snoring like a hacksaw. Sounds ridiculous. So I sneak over, grab the remote from his hand. I'm like, oh yeah, he didn't wake up. He didn't wake up. I go over and change the channel. And all of a sudden he wakes up. Hey, I was watching that. It's like, what? How? I feel like everybody can relate to that. I mean, I don't understand how they can figure it out. What's that?
Thermometer changes wonder.
Yeah. Or you leave the door open for a little bit. What are we heating outside here? Come on now. Yeah, I always thought it was interesting. His absolute threshold's being triggered, even though he's sound asleep and somehow can realize that I changed the channel. Like, wait a minute, how? His signal detection theory must have picked it up. Oh, it's funny. It's funny. All right, is there any questions on that, guys? So we're good with absolute threshold, sensory adaptation, signal detection theory. We talked about Weber's law. We talked about Fechner's law. Don't worry about Stephen Powers' law too much. That just kind of goes along with those two laws as well, just how we can perceive a just noticeable difference or a difference threshold is being triggered. Okay. Again, Weber's law is that percentage difference. Even though you might be saving $1, right? You're saving that dollar depending on the item. That could be totally different, right? It's like, oh, well, I'm not really saving much if I'm dumping $79 down instead of $80 for this shirt. Wow. Okay. Is there any questions? You guys good? All right. I had an assignment for you, but how about I save it for tomorrow? What? Okay.